other than that, I also think it's very important that, especially during this time of COVID, we can't take it for granted that we are here and that God has enabled us to be here. So I would really like for one of you to volunteer, to just pray for us all and to just pray for the whole world as we're tackling this pandemic. So many people are hurting, so we can't take it for granted that you're here. So if you can be able to just unmute yourself and pray, please go ahead and do.
Let's pray. In the name of the Father, the Son, and the Holy Spirit. Our Heavenly Father, as we come before this day, we thank you for being with us and giving us the strength for today. As we're going to start this session, we pray that may be with us. Give us the strength and the power to understand everything that's going to be taught. In Jesus' name, I do pray, believe, and trusting. Amen.
Amen. Thank you, Winnie. So I'm just going to share my screen. I'm going to share the YouTube playlist for the previous sessions for those who missed it. So you can just be able to catch up on that. So we are going to be using our studio, obviously. So we are tackling exploratory data analysis. So this is just how we use visualization and transformation to explore data in a systematic way. So the short form for it is EDA. So it's an iterative cycle. So we know iterative really means it's like it's going in loops. So that's what will happen. So what we'll do will just be questioning our data. So, and then search for answers for those data through visualizing, transforming, and modeling our data. So we shall also be able to just go ahead and as we are questioning the data, we are going to be able to create more questions from that data and just still get answers. So the questions really don't have like a guideline or a rule of how you're going to question the data, since at the end of the day it's your opinion as a data scientist. What are you looking for in that data, or what conclusions are you trying to get from that data? So there are two types of questions we will use that will be useful for us. That is the type of variation that occurs within the variables and the type of covariation that occurs between the variables. So that's really what you're going to look at today. So we're going to start off by defining some terms. So I have already written out the short notes as comments on the RStudio. I have also written out the code just to guide us, so that in case you have any question, drop it on the chat section. And also it also enables you, and it also gives you time to open up your RStudio if you have it, and then you can just be progressing as you do. However, I will also share the GitHub link to this repository. Okay, so a variable is a quantity, quality, or property that you can measure, and a value is the state of a variable when you measure it. The value of a variable may change from measurement to measurement. We also have an observation, which is a set of measurements made under similar conditions. You can make all of the measurements in the observation at the same time on the same object. An observation will contain several values. each associated with a different variable. So I will sometimes refer to an observation as a data point. Um, so if you have any question, just make sure you drop it in the chat section. I shall be able to see it. And then we have tabular data is a set of values, each associated with a variable and an observation. Tabular data is tidy if each value is placed in its own cell, each variable in its own column, and each observation in its own row. So that's tabular data, and we consider it tidy if it is placed in its own column, in its own row, and its own cell. It's tidy. And then variation. So variation is the tendency of the values of a variable to change from measurement to measurement. And this is something we have been able to see. Probably you can be looking at an observation of a value or the variation of a value from the mean. That's when you can have like the upper quartile, the lower quartile, and such. Each variable has its own pattern of variation, which can reveal interesting information. The best way to understand that pattern is to visualize the distribution of the variable values. So I believe that is realistic because you can imagine a data set with columns, and each column have its own values. So if you're differentiating from the mean, of course, each column will have its own pattern, especially if the values are different from each other. So visualizing distributions. So how you visualize the distribution of a variable will depend on whether the variable is categorical or continuous. A variable is categorical if it can only take one small set of values. In R, categorical variables are usually saved as factors or character vectors. So to examine the distribution of a categorical variable, we can use a bar chart. So to be able to use the bar chart, of course, we are going to have to install the package that is going to enable us to have that chart. So that package is the ggplot2 package. And you have to install it first using the install.packages and then put it in quotation and then load it up on your Visual Studio using the library ggplot2. So the function itself, for you to be able to plot that bar chart, is known as ggplot, but the package is ggplot2. So once I run that, so I'm just, for those who haven't been in the previous sessions, when you're creating, sorry, I wanted to see the chat. When you're creating your R document, you have to load it up and then save it as a .rmd. Whichever name you're going to give it, you're just going to, okay, let's say if I have a new file. So for those who have been here in the previous sessions, let us just help out the people who are following with us. So you can either come and do all this, go to new file, create my title, or it will automatically have its own title. I mean, not its own title, it will automatically have a file written and titled at the top. So the one thing you should do, let me just make sure I increase my volume. The one thing you should do is now come and save it. So for example, if you want to say trial, the name of your file, and then you can just, okay, since this one is already an R markdown, I don't really need to add the .rmd. Okay, no, I do. So if probably it has yours has come up like this, so you can just click on save. Guys, can you guys can't hear me? Trial.rmd. That means R markdown. Wait. Somebody is saying that they can't hear. Winnie is saying I am audible. Okay, you're so okay. I think it's his or her audio. So you should first save it as an RMD. Once you save it, you shall now be able to load up the packages. So, and then click on whichever package you want to, if you're typing word by word, you can just click on it and then run the selected lines. So if your codes are next to each other, like you can see mine are, there's no space in between. Even if I click on the last line, it will also run the first line automatically. So that's what will happen. So if you just run it, so I've already run it. So on my console, I can see that, okay, no, I haven't. Let me run it. You should be able to see that happening. You can see the process happening and you can see the stop sign. So for those who are in the other group, the data science you're in, this was part of the Data Science East Africa Bootcamp. So I have just sought to share the link with you so that you can be able to join. So don't panic. You shall be able to get access to the videos if you just want to rewatch, but we shall still have a session with you. So because I can see that discussion going on WhatsApp, so don't worry about that. Just a chance for you to learn something before. I hope that is clear. Okay, so looks like my code has finished. Okay, it hasn't. So you will see it downloading those packages. Remember to put your package name in a quotation, in quotation marks, ggplot2. That's our package to help us use the ggplot function. So it has already done that. Once it does that successfully, you shall see this in your console, and it will actually tell you that that has been successful. If it's not successful, it will also tell you that that was not successful. So I hope that is understandable. So we shall now be using R has several data. R has several data sets that are already in the R Studio itself. So if you come here at, okay, if I come here in my console, probably I want to, so I'm going to use the data set diamonds. So I can just say question mark diamonds. Probably you just want to find out more about that data set. So you can see on this end of the pane, okay, it has already even, this is the home, yeah. So that, you see, it gives me information about that data set, diamonds. This is a data set containing prices and other attributes of almost 54,000 diamonds. It has those rows and 10 variables. So the variables are price, carat, cut, color, and it just goes on to explain clarity, length, width, depth. So that's how you find something or you ask for help in R. You just put a question mark in front and it shall guide you. So I just wanted to show that. So so I have plotted the plot. So we are creating a bar chart. So how do I know that it has created a bar chart? Though this one we touched on the previous lessons, but we know because ggplot first use the function, call the function for plotting ggplot, data is equals to diamonds because I want to use the diamonds data, plus, note where the plus is, and then g on bar. Once I say G on bar, it automatically knows that these are this is a bar chart that is being created. And then mapping is equals to AES means aesthetics, where the X is equals to cut. So if you can remember well, in the bar chart, okay, probably we used to do this when we were in high school, probably used to put the y value, but the bar chart, the y intercept is usually the frequency. So the ggplot automatically uses a start function to calculate the number of rows of that specific variable. So for ours is cut. There are different types of cut. As you come here in our data set, you can see there are different types of cut. There's a fair, good, very good, premium, and ideal. So it will automatically count how many rows are being occupied by the fair, how many are being occupied by the good and very good. So I don't need to define that. It will automatically do that for us. So, and then you see the plot, and there is the plot. Fair, good, very good, premium, and ideal. Okay, so the height of the bars displays how many observations occurred in each x value. You can compute the values manually using deep layer 2 full colons count. So we are going to do that. So if you see well, we have this pipe function or this pipe operator. It has like two percentages, a less sign, and percentages. So for me to be able to call out this function, I mean this operator, I have to load it up using these packages, the Magritter and the dplyr. So these are things we have also looked into before in the previous classes. So once it asks you this, and I remember we had somebody who kept asking this question, do you want to restart our prior install? Just say no, no, I don't, and move on. Don't type yes, just say no and move on with your code. So I have installed the package and I have also loaded it up. To load it up, use library. To install, use install.packages, put that package in quotation marks, but when you're loading it up as a library, you don't put it in as quotation marks, in quotation marks. Yeah, so I'm now going to just get that count, though I have displayed it as a table. So a table will just show us you can see it's a table, a 5x2. It's just a table. So it shows us that fair, this is the count, good, this is the count, very good, premium, and ideal. So this is what was plotted before, only that probably in case if in the plot you really can't see or you can't figure out the exact value, it gives you that option of being able to find out what that value is. Okay, so let us move on. So a variable is continuous if it can take any of the infinite set of ordered values. Numbers and date times are true examples of continuous variables. To examine the distribution of a continuous variable, use a histogram. So remember what we were looking at before was categorical. And if you remember, In R categorical variable, I usually saved as factors or character vectors. A variable is categorical if it can only take one of a small set of values. So now we are moving on to continuous. Yeah. So we have said numbers and date times are two examples of continuous variables. So we are going to still use our ggplot function. Our data is still diamonds. And then we are going to use now a histogram. The mapping is equals to aesthetics. X, you're going to put the carat, and then the width shall be 0.5. So let us see how that is going to be displayed. So you can see how that looks now. We have the carat here, and then the count, of course, and then now it looks at the width. So yeah, that's that. So a histogram divides the x-axis into equally spaced bins and then uses the height of the bar to display the number of the observations that fall in each bin. In the graph above, the tallest bar, which is here, that's almost 30,000 observation of each carat value between 0.25 to 0.75, which which are the left and the right edges of the bar. So yeah, I remember if in high school we just check where this starts and where it ends. So same thing here. Or for those who probably, I don't know, where you were able to cover histograms even in primary school, I guess. So you can set the width of the intervals in a histogram with a bin width argument. So for me, remember I used the bin width 0.5. I have skipped this part, but I will come back to it. And then always explore a variety of bin widths when working with histograms, as different with bin widths can reveal different patterns. I believe that that's definite. If probably I use 1.0, it shall be different from 0.1, or 0.75, it shall be different. So you can compute this by hand by combining the dplayer count and ggplot cat underscore width. So I believe here you are finding also the count. Let's see. They're displaying the histogram now as a table. So you can see in each and every interval it's 0.5. So from 0.2 negative 0.25 to 0.5, we have 785. From 0.725 to 0.75, we have 29,498. So it gives you definite values that probably you might not be able to find out from the histogram directly. Okay, so let us move on. So we can declare variable smaller, and then diamonds, the pip, and then filter carat that is less than 3. So if I run that, and then first I have here is just for declaring the variable smaller, and then you come ahead and say ggplot data is equals to smaller, this data set that you have just declared, the mapping with the aesthetics x is equals to carat plus, so we are going to map a histogram with bin width of 0.1. So you can remember the bin width we did before was 0.5. So for this is 0.1. So remember we have said that our data set is going to be smaller. We declared it a variable smaller where the diamonds, we filter any carat that is less than 3. So if you look at that, you can see how that data is a little bit different, and you can see it's only from 1 to 2. So you can see the range that you're able to see. So probably you can be able to spot things you are not able to see if you had generalized the whole data set. So it's able to be more distinctive. So to overlay multiple histograms on one plot, we can use the geom freq poly instead of the geom histogram. So the geom freq poly performs the same calculations as the geom histogram, but instead of displaying the counts with bars, it uses lines instead. So it's a polygon, in other words. So we are using a polygon. So instead, we shall now use the geom freq poly function. So since of course you can imagine having a data having two histograms on top of each other, that's a little bit hard to read and to make conclusions from and like align. So I'm just going to run that. So I'm going to use the ggplot function. Data is equals to smaller. So this data set that we declared here, yeah, you see where we said smaller is equals to diamonds, where we filter anything that has a carat of less than 3. So that is what we're using. So that data is equals to smaller, mapping aesthetics x is equals to carat, color is equals to cat. So the color of my polygon will be the cat. Okay, the x-axis will be my carat plus geom, no, calling or declaring the polygon, now you give it a bin width of 0.1. So let us run that so you can see how it looks. So you can see it's able to give us, remember the cat was the color. So we are able to see that ideal takes the yellow, so this is called the legend. Green is premium, so we can see where the premium is. Very good is, I think, it's a little bit of blue, you can see where it is. And good is a little bit, I think it's a little bit of like dark blue or something, or navy blue, so you can see it. And then purple being the fair. So you're able to see, so you can even see that the count for ideal, where it is less than 3 carats, it's greater, with fair being less. So yeah, I think it makes sense because ideal is like high quality. So the people who are going probably to buy 3 carats and less is gonna be, they're gonna be higher. While for the fair, you can see the people who are buying it picks up at 1 carat, but you can see for ideal it was this is like less than, it's around 0.25. So that makes sense. So if you have a question, remember you can just drop it in the chat section. So let me just make sure. Okay, so we have what we call unusual values. Outliers are observations that are unusual, data points that don't seem to fit a pattern. That's the definition of an outlier. Sometimes outliers are data entry errors. Other times outliers suggest important new science. The distribution of, so you can imagine if you're taking in data for gender and you have male, female, and rather not say. So when you're coming up and making conclusions from that data, especially using box plots. Outliers are, I will show you very soon how outliers are displayed. It will let you know as once you see that the outliers are actually more, it will make you as the person who is creating the form or on the other side of receiving the data to be like, okay, what is actually what should I be focusing on so that I can capture the rather not say part well, so that I can be able to know, okay, so what do they mean? So that's just it. So, and then the distribution of the y variable from the diamond data set, the only evidence of outliers is the unusually wide limits on the x-axis. So they created a ggplot. They used the ggplot function, use the dataset diamonds geom histogram mapping aesthetics x is equals to y, and then the bin width of 0.5. So let us run this and see. Yeah, so I guess that's why they say the outliers is the unusually wide limits of the x-axis, because the limit, if you can look at this data set well, you can see it's like it's lean, it's hardly even in the first half or first quarter of our plot. So it means that the width that was used is not realistic. So that's our outlay in this case. Okay, there are so many observations in the common beans that the rare beans are so short that they don't usually see them. So sometimes you might be having a data, and when you're looking at it, you, in real sense, there's so much into the data, but if you display it graphically, you miss out the small parts that are being represented in the data set, because probably those small parts are combining and making something. So you're not really able to get that definitive visualization of that data completely. So to make it easy to see the unusual values, we need to zoom two small values of the y-axis with the code Cartesian function. So that's what we shall use to be able to get that focus of those values that probably we're missing because of how we have displayed our data. So we'll still call out the ggplot, diamonds, geom histogram, mapping is equals to aesthetics, x is equals to y, bin width is equals to 0.5. So they're expounding on this data set that we have here. So code Cartesian y lim is equals to, this is a vector. C, whenever you see C in the brackets, that's a vector being defined. So from 0 to 50. Let us see how that will run. So you can see how that looks like now. This is the previous one, and this is what we have now. So you can see it looks like we almost missed all this. And if you look at this data set well, this part is combined here, but here it's kind of separate. So we are able to see that it's actually not continuous. There's some part that has no information. So, and then you're able to see that this is actually wider than we had actually thought it was, or we could see in the previous data set. Okay, so missing values. Hey, is there anybody with a question? So far, is there anybody with a question? Let me just grab something. So if you feel you have a question or there's any point you need me to expound more, just tell me before I move on. So then let us move on. I can see any question. Okay. So missing values. Have I been dropped off the call? Oh no, I don't think so. Okay, missing values. If you've encountered unusual values in your data set and simply want to move on to the rest of your analysis, you have two options. So remember, sometimes you can be gathering information, probably even when you're told to fill a form, you miss out some parts of that form because probably it's not compulsory for you to fill out that information. So you can be skipping that section of that form. And when that person goes ahead and wants to analyze that data, they have two options. They can either drop that entire row, probably remove that specific row for that individual who has missed out that part, or where you have that missing value, replace it with a substitute. So to drop out the entire row, you can come and declare diamonds too. So we declare the variable in R using the less sign and the dash. So diamonds is less than okay, is equals to, I mean diamonds 2 is equals to diamonds, where we filter between y and between 3 and 20. So probably if there's nothing like that, it drops out anything that is not between that value, and that's really not a good idea because probably it has information that you need. The other rows have information that you can use, so it's not a recommended way. So let us look at what we can be able to do. So just because one of the measurements is invalid doesn't mean all the measurements are. Additionally, if you have low quality data, by time that you have applied this approach to every variable, you might find that you don't have any data left, which is very true. If you're going to filter out that you only want responses where everybody has filled in each and every value that you requested for, and probably you didn't make it compulsory, it will limit the data that you shall have. You shall not have probably a wide scope of data for you to be able to analyze. You might end up not having any data at all, or it might reduce the quality of the data. And when I mean by quality is you might have had 100 people to 100 rows or information from 100 people that you could have been able to analyze, and you're left with 20. That's low quality data because that 100 would have reflected more information than the 20 would when you're analyzing the data. So like I have said, the other option is replacing the unusual value with the missing value. So the easiest way to do this is use the mutate function to replace the variable with a modified copy. Use the if else function to replace unusual values with NA. You all know NA what means, not available. So you can come and say diamonds 2 is equals to diamonds, the pipe function, mutate y is equals to if else y is less than 3 or y is greater than 20, not available, y. So let me explain what that code does. So the if else has 3 arguments. The first argument, test, should be a logical vector. The result will contain the value of the second argument, yes, when the test is true, and the value of the third argument is no when it is false. So if it finds that your data is not in between that, it will take the third argument. That's just it. And then Yeah. So this one will check, is it NA? Yes. Um, is it, if it's false, then it's our Y. Alternatively, to if else, use deep layer, two full colons, case underscore when. So case when is particularly useful inside mutate when you want to create a new variable that relies on a complex combination of existing variables. You should not plot missing values. So ggplot doesn't include them in the plot, but it does warn they are being removed. So let us see how it warns us. It warns us. So you have the ggplot function, the data is equals to diamonds2. So there is no data set in R called diamonds2, but we defined diamonds2 here. We came and defined diamonds2, if you remember, where we said y should be less than 3, or y should be greater than 20, or not available. If it is not either of these, make it y. So that is what is happening. Data is equals to diamonds2, mapping is equals to aesthetics, where x is equals to x, y is equals to y, plus, remember the plus is always on this line. It is not on this line. So that is something you shall see if you had missed the previous lessons. It is something you should note. And then plus geom point. So you can also, R also gives you the advantage of combining 12 more graphs. So if you want to also include a polygon, you can just come ahead and do plus geom polygon. So, and then you can also customize the values, but already here we customize the values here by default when we put it up here in the ggplot function. So if I run this, so geom point gives us a scatter plot. And that is what has happened. It has given us a scatter plot. If you notice, some of the areas of that scatter plot, it looks to be really congested. There's a lot of overlapping of values. It's really hard for you to be able to really make out which data is which. But that is that. But we also touched on this in the previous classes, how to be able to use jitter to just spread out the points. So that is something you can be able to look out for in the previous lessons. So to suppress that warning, okay, this was the warning that it told us here in the console. There's a warning once I ran out that function. It told me removed 9 rows containing missing values. So we don't want that to happen. We don't want it to remove those rows. So what do? You come ahead and say and na.rm is equals to true. What does this mean? It means not available, remove is equals to true. So if I run this, okay, in case, okay, the beauty of R is this, in case you don't really understand what is happening, or maybe what a certain command is doing for you, and just come ahead and say question mark. Remember we talked about this before. NA, you can just put it in caps .rm. So if I run this, wait, has that been executed? Documentation. You should try. Okay, just put a double quotation question mark. We see if it will work. Okay, it's too small. So one thing is that R is case sensitive. R is case sensitive, so that's something you should also note. Okay, let's see if that will work. has refused. But you should just know that the NA, but in one of the lessons, I was able to touch on how to use the NA.rm. That's also slipped my mind. But it just means, do I remove the NA values, like the not available values? If you say false, it will plot it with them. If you say true, it will be removed without giving a warning. So for this case, it will just run the code, but it won't give us a warning anymore that it has been removed. So you can see. So sometimes you want to understand what makes observations with missing values different from observations with recorded values. For example, in the NYC flights, so this is a data set as well, and this is something we looked at in the previous class, NYC flight 13, flights, missing values in the departure time. So if I just click on it, just in matters of interest of those who are not able to see this while we did it, question mark, NYC flights. Okay, let me remove that. Let me remove this. Leave those flights. Okay. Sometimes a studio might decide to NYC, I don't know if it's NYC 13. Let me just run that. Okay. Okay. Yeah. This is the data set, NYC flights. I don't know why it wasn't accepting, but here it is. It does not focus on the past. So you can see this is a data set version of NYC 13 data. This functions cache the data from database in a local database, blah, blah, blah. So, it hasn't really given me what I wanted. But there's that data set that is able to explain that for us well. So it's there in the previous class. So yeah, so what was I? So we want to look at the missing values in the departure time variable indicate that the flight was cancelled. So that data set has arrival time, departure time, wherever it's landing, the time of the duration. I think it also has the flight, the tail number. So in the departure time, some rows are missing values in that data set. So that means that flight was cancelled. So we might want to compare the scheduled departure time for cancelled and non-cancelled flights. You can do this by making a new variable with is dot na, meaning values that have the not available that are not available is dot na function. I hope it's making sense. So it can come ahead now and say New York, okay, New York City flights. They're New York City flights mostly, and then flights is the prep function. We say it's cancelled is equals to is dot na departure time. So you're just saying that the variable cancelled is for the values where you have no they are not available, where the values are not available in the departure time. And then scheduled hour, and then scheduled hour is equals to the scheduled departure time divided by 100, and then scheduled minute is the scheduled departure time by 100, and then scheduled departure time is the scheduled hour plus the scheduled minutes divided by 60. So ggplot is equals to mapping is equals to aesthetics scheduled departure time plus frequency geom frequency polygon mapping aesthetics color is equals to cancelled. So it will be a polygon where the lines the color will be representing the cancelled, and then the width is a quarter or 0.5. So if I run this, okay, have I put in? So you have to make sure that your cursor is where you want it to run. So this is our plot. This is now our plot. So you can see that the red represents the cancelled and the green represents the not cancelled. So yeah, schedule, departure time, count. So you can see what you're able to. So you're able to see the cancelled with reference with the not cancelled. So let us move on. Yeah, so let us look at covariation. Variation describes the behavior within a variable. Covariation describes the behavior between the variables. So covariation is the tendency of the values of two or more variables to vary together in a related way. The best way to spot covariation is to visualize the relationship between two or more variables. How you do that should depend on the types of variables involved. So since it's how two or more variables vary together in the related way, so it's very important to note the variables that you're picking to compare that variation. So we have a categorical and a continuous variable. So it is common to want to explore the distribution of a continuous variable broken down by a categorical variable, as we did on flights in the previous example. So to the default appearance of the frequency polygon is not that useful for that sort of comparison because the height is given by count. That means if one of the groups is much smaller than the others, it is hard to see the differences in shape. For example, let us explore the price of diamond varies with its quality. So basically, um, we are okay. They're just saying that it is not as useful for us to do the comparison that we just did, because at the end of the day, the height is dependent on the count. So if one of the groups is much smaller than the others, it's hard to see the differences in shape. So you can imagine, you can even see for the not cancelled, the height was pretty slow. So if you had other variables, it would have been hard for you to make a conclusion. So let us see how the price of diamond varies with its quality. So ggplot data is equals to diamonds, mapping is equals to aesthetics, where x is equals to the price, plus the geom frequency polygon, where mapping is equals to aesthetics, color is equals to the cut, so the color will represent the cut, and then they'll have a beam width of 500. So let us run that. So you can see this is what we have. Yeah, that is what we had. I think we had highlighted this before. Okay, but this is for price. So the issue they have with this is that it is hard to see the difference in distribution because the overall counts differ so much. So they did this as a bar graph as well. So let us see if for a bar graph it will be easier. So this is for the bar graph. So did I skip something? Okay. So to make the comparison easier, we need to swap what is displayed on the y-axis. Instead of displaying the count, um, we will display density, which is the count standardized so that the area under each frequency polygon is 1. So let us standardize that count to only display the the density. So how do we do that? You come ahead. So ggplot data is equals to diamonds, mapping is equals to aesthetics, where x is equals to the price, y is equals to the density. So not how I have written the density. So let me just mute that. Plus, so plus should always be at the line before, yeah. Plus geom, frequent polygon, mapping is equals to aesthetics, color is equals to cut, bin width is equals to 500. So if I run this, let's see the comparison between that and what we had before. Yeah, so you can see we are able to have we are able to actually define this well. Look at how different this graph is and what we had before. This is what we had. So you see, this is just based on the count. So we are not really able to make, you can see for the fair, because it's just represented in less rows, it's making us hard to be able to make a fair covariance between those observations. So, but once we decided to use the density, you can see how the fair is. The fair looks to actually have a higher density, a higher, is more defined than actually all the others. So that is why they standardize that and use the density. So any question? Any question up to that point? Yeah. So conclusion, it appears that fair diamonds, the lowest quality, have the highest average price. And that is very true. If you look at this graph, it shows that the fair has the highest average price just from where it is positioned. Um, Whereas when you are looking at it from this point, you can see it seemed like it wasn't actually doing as well. So that's why we change what is being displayed on the y value to be the density. So this is because frequency polygons are a little bit hard to interpret. That is, there's a lot going on the plot. Another alternative way to display the distribution of a continuous variable broken down by a categorical variable is a box plot. So each box plot consists of a box that stretches out from the 25th percentile, known as the distribution, and the 70 to the 75th percentile. So remember that's like the lower percentile and the higher percentile, and then the distance is known as the interquartile range. In the middle of the box is a line that displays the median, that is the 50th percentile of the distribution. These three lines give you the sense of the spread of distribution, whether or not the distribution is symmetric about the median or skewed to one side. So it also has visual points that display observation that fall more than 1.5 times of the IQR, that is the interquartile range, either from either edge of the box. These outlying points are unusual, so are plotted individually. And then a line or whisker that extends from each end of the box and goes to the farthest non-outlier point in the distribution. So I mentioned the outlier. So I'm going to share with you this image. So you can, though I will also share it here. Do I need to share it with you? I don't actually think I need to. I can just show it to you from here. So let us look how that box plot is represented. Okay, let me just get it. Sorry. So let me just get it. So if I just load it up. So that is how our diagram is looking like. So these are the actual values of the distribution. This is how the histogram would display the values. So you can you can flip the histogram using the chord flip, and this is something we have looked at the previous sessions. So now the box plot will display these values this way. So here are our outliers, remember the unusual values, and then we have the whisker to the farthest non-outlier point, and then we have the 75th percentile, we have the 50th percentile, which is our median, and then we have the 25th percentile. So this whole point is the interquartile range, and then this part is 1.5 of the interquartile range. So that is that. So let's look at the distribution of price by cut using the box plot. So you're going to plot a ggplot that is equals to diamond, mapping is equals to aesthetics, where x is equals to cut, y is equals to price, using the box plot. So geom box plot to use that. So that is how our graphs looks like. So from this you can be able to see where the lower quartile of the fair is, the upper quartile, and then we have the median. You can see for the good where it is, the median. You can see the interquartile range for the very good is a little bit um, longer than for the good, and the good is longer than for the fair. So you can see where our median is. The premium has a larger interquartile range. You can see where our median is, looks to have a larger median than all, if I'm not wrong. And then we can see for the ideal how it looks like. So yeah, so we can also see our whisker and our outliers. So remember, if you have a question or you want me to repeat something, just drop it in the chat section. And then the box plots are much more compact, so we can so we can easily compare them, and you can also fit more on one plot. Conclusion: it supports the counterintuitive finding that better quality diamonds are cheaper on average. So we can see that better quality is cheaper than, wait, yeah, better quality diamonds are cheaper on average. So let us look at that. So our fair, this is our average, good, um, very good, premium. So I think that this median is a little bit higher than the others. So it looks like it's actually doing better than even the fair or the ideal. So CRAT is an ordered factor. Fair is worse than good. We saw that. Fair, the interquartile range is less than the good. And we also saw which is worse than the very good. So the very good is doing better than the fair, and so forth. So many categorical variables don't have such intrinsic order. So you might want to reorder them to make the information more informative. One way to do this is using the reorder function. So in case you just want to automatically, when somebody looks for it, they're not really figuring out, okay, so which one is doing better than the other one? So you can use the reorder function. So how is that done? For example, take the class variable in the MPG dataset. So there's also a dataset known as the MPG, which we looked at last time. So to just find out more about that dataset, so I don't know if this time it will cooperate with me. Let us see. Do question mark. So you'll just do question mark. Where's my question mark? Okay, question mark MPG. Does run this good? Okay, yeah, it has come up. So probably for flights, I don't really remember how you are typing that name. Don't remember the exact name. So don't want to lose that. So you can see the MPG's fuel economy data from 1999 to 2008 of 38 models, 38 popular models of cars. So it has manufacturer, model, that means engine displacement, year, cylinders, number of cylinders, type of transmission, type of drive. Is it a front wheel drive, a rear wheel drive, and a four wheel drive? City miles in gallon, highway miles per gallon, fuel type, and the type and class, meaning the type of car. So we were able to really get into that data type even for the flights in the previous session. So once I send them to you, you can just be able to look into that and just see how we were able to do that. So ggplot data is equals to MPG, mapping is equals to aesthetics, where X is the class and Y is the highway miles per gallon. You can even see. So geom box plot. So let me run that. So this is our data set now. That is our data set. So you can see how the two-seater looking, no outliers, compact, several outliers. Also, it's very important for you to note this whisker, this whisker to farthest non-outlier point. It's very important for you to note that when you're analyzing. So you can see even just the height, the distance from that to the farthest outlier point is really important. Even when you are looking at this, it's very important that you note that range. So yeah, so that is that. Um, you can easily be able to know, you can easily see that the compact had a larger interquartile range. Probably that the median of the, let me just maximize this once again. The median of the SUV is a little bit low, but of course for the pickup is the lowest median. Um, and then yeah, so for the minivan and for the two-seater looks like the range between the lower quartile, the median, and the upper quartile is a little bit uniform, unlike for the others. So to make the trend easier to see, we can reorder class based on the median value of the highway miles per gallon. Yeah, highway miles per gallon. So how do I do that? So data plot, ggplot data is equals to mpg, and then we have the geom box plot, mapping aesthetics x reorder. Remember the reordering to just be able to know, okay, which one is starting, which one is the lowest, and then class, where class meant the type of car, and then highway miles per gallon, where the function is equals to median, and where y is the highway miles per gallon. So let me run that so we can be able to see how that. So it has been reordered based on the median. It has been reordered based on the median. So we're able to see as the median increases, we're able to see which one has the highest median. That's the mid-size type of car. Um, yeah. So it makes it easier for us to be able to analyze that data and make conclusion from it faster. So if you have long variable names like we have here, geom box plot will work better if you flip it 90%. So you can make the values that are on the y-axis, I mean on the x-axis to be on the y-axis, and also on the y-axis to be on the y-x-axis. To do that, you use the chord flip. And also talked about this, even with your histogram, you can use a chord flip to just flip that diagram. So these are the same dimensions, only that they have included the chord flip. So once I run that, so you can see how now my graph looks. So, or my plot looks like. Okay. So, um, two categorical variables. So to visualize the covariation between categorical variables, you will need to count the number of observation for each combination. We can use geom count. So ggplot data is equals to diamonds, and then geom count mapping is equals to aesthetics, where x is equals to cat and y is equals to color. So if we run this, So you see, we can be able to see, remember we had the color in our data set for diamonds. It was one of the variables. So we are able to see the color and X being the cut. And then the geom count is able to help us to count the number of observation in each combination. So for the D, that's the count, and you're able to see those values from here. So you're able to know in the ideal where the color is G, you have roughly 4,000. Then 3,000 where the color is F. So that's just a way to be able to analyze that data set. And then, yeah. So the size of each circle in the plot or in the plot displays how many observations occurred in each combination of values. Covariation will appear as a strong correlation between specific X values and Y values. Another approach to compute the count is using the deep layer. So you can remember us using this. So you can just get the count in form of a table. So here are our values. So for the D, where there's fair, you have 163 values. Let me just increase that. So fair D, this is 163, and you can actually see that small dot is not represented in our legend. So let us look at D, very good, 15, 13. Very good. So this one looks like we're around 1,000. So the only thing is that is of course it won't be as definitive to you for you to get the exact values, but of course now using the count you can be able to know what the exact values are, and that's what we have been able to do. So we're almost winding up. So then visualize with geom tile and the fill aesthetics. So diamonds, pipe function, count, color, and cut. ggplot mapping is equals to aesthetics, where X is equals to color, Y is equals to count. And then the geom tile mapping, where aesthetics is equals to fill is equals to N, where now it fills with color our N values. So let us see how this will look like. So if I eliminate this, so you can see how that is looking like. So now that data has now been represented like that. So you can see that data that we had before has now represented using a geom tile. Okay, so mainly, okay, I'm winding up. So today I was just winding up on data visualization. That's why we're still looking at a lot of graphs. So that's basically it. I have really been covering a lot on data visualization. Yeah, let me first finish. I just wanted to point out why we have been doing a lot of graphical commands. Okay, so yeah, so here we are. So two continuous variables. So these were two categorical variables. So what if you have two continuous variables? As seen, only one way to visualize the covariation between two continuous variables is to draw a scatter plot with geom point. Let's look at the exponential relationship between the carat size and the price of the diamond. So to do that, we shall, of course, use the ggplot. Data is equals to diamonds. Geom point mapping is equals to aesthetics, where X is equals to carat and Y is equals to price. So if I run that, so you can see how that looks like. So of course, top right or immediately as you look at that, there's a lot of overlapping of content. There's a lot of overlapping of content and information. So that's why it's a majority of dark spots. So what can we do to improve that so that we can be able probably to visualize our data better and make conclusions from it? You can just come ahead and yeah. So just more information, scatter plots become less useful as the size of your data set grows because points begin to overplot and pile up into areas of uniform black as seen above. One way to fix this problem is using alpha aesthetic to add transparency. Now, this is something that we also touched on in the previous classes. So how do we implement the transparency? So ggplot, data is equals to diamonds, g on point, mapping is equals to aesthetics, where x is equals to carats, and y is equals to price. And then alpha is equals to 1, so 1 over 100. So let us see how that will look like. So yeah, so you can see how our plot now looks like. I don't know if you guys can be able to see that transparency. But you can, if you look closer at it, you can even see points um to at this point. There's even a point here. So yeah, so that's what transparency does for us. So transparency can be challenging for very large data sets. So another solution is to use bin. Previously, we used geom histogram and geom frequency poly to bin in one dimension. Now, we will learn how to use geom bin 2D and geom hex to bin two dimensions. So geom bin 2D and geom hex divide the coordinates into 2D bins and then use a fill color to display how many points fall into each bin. So the geom bin 2D function creates a rectangular bin and the geom bin hex creates hexagonal bins. We will need to install the hex bin package to use the hex. So first we shall start with the bin 2D, the geom bin 2D. So of course you still use the ggplot, data is equals to smaller, and then geom bin 2D mapping is equals to aesthetics, where x is equals to carats and y is equals to price. So if I run that, so this is how our data now looks like. So using the fill, I can be able to see where the data lies. Okay, so you can be able to see this is where we have like the light green, the light blue. So that's where we have where the count is around 6,000. And then we now have the region, the other region where it's a little bit dark, that's being around 4,000. So I think it's the surrounding area, these points, and then now we have whatever it's from up to from okay, I think this is between 2,000 to 4,000, and this is anything that is lesser than 2,000, and this is between 4,000 to 6,000. So it just shows the count of probably less than one, and the price is around less than 5,000. That's our count. So it's just showing that using that now the color. So let us use now the geom hex, which will show hexagonal bins. So they have said we should need to install that package. So I installed it. Okay, so it's done. And then now I run that. So ggplot data is equals to smaller, geom hex mapping is equals to. So remember smaller, there's no data set called smaller, but we declared a variable called smaller and filtered the data set. The diamonds, it was less, anything that the carat is less than 3. So that variable is now what is being taken in as data. And then geom hex mapping is equals to aesthetics, where x is equals to carats and y is equals to price. Same thing, only that now we have changed the function to geom hex. So let us run that. So if you notice, um, they form hexadecimals. They form hexadecimals. It's no longer squares like for this. This were, and then these are rectangles, sorry. And then now this form not hexadecimals, hexagonals. So we have same thing, 6,000 and greater, that's our color. And then between 4,000 and 6,000, that's our color. And then where the count is between 2,000 and 4,000, that's our color. So these points. And then anything that is less than 2,000 occupies the rest of the plot. So that's the end of my session. That's what I had prepared. We are done with Explore EDA. We are done with EDA. So next time we have 3 major subtopics remaining. I know it looks like we're almost finishing, but we have a lot of work ahead. So I don't think we are as near as we think because we have data wrangling. We also just introduce Python functionalities and then programming functionalities like how to use the if else, things that we use in not Python R, things that we also use in Python, the if else functions, I mean the loops and everything. And then we shall also look at models. That's where we shall look at some test of hypotheses and such. Other than that, that's when we'll be done with like the introductory part of R. So yeah, I hope we shall just God will give us the grace to just be able to do them and cover as much as we can. Other than that, that's the end of my session. If you have a question, even if it's not related to this class, if you have any R question, you can ask. If there's none, we can end the session there. Can you share the RMD file? Yes, I will share. I will post it on my GitHub, and then I will share the link on either the WhatsApp channel, both WhatsApp channels, so that you can be able to see it. Yes, that's the only way I can be able to share it, Mandela. Once I post it on GitHub, and then the student can be able to clone it and then learn from it, or you can just be able, you don't have to clone it, you can just be able to look at it while you're coding and compare. It will have the comments, the explanations, and also the code itself. So thank you for everyone who has been able to stay till the end of the session. I believe I am done for today. So thank you.